Hi and Assalamualaikum everyone. In previous chapter, we have done on correlation analysis to understand the strength and direction of linear relationship between two continuous variables. We have discussed the Pearson correlation coefficient and how it measures the linear association between variables where the value can range between -1 and 1. Now, in this chapter, we will explore simple linear regression, a fundamental statistical technique where it helps us understand and model the relationship between two variables, dependent variable, the outcome that we are interested in predicting, and an independent variable, the predictor. This method is widely used in various fields such as economics, biology, and social sciences to make predictions and understand the strength and direction of relationships. In this video, I'm going to show you how to perform and interpret a simple linear regression using SPSS software. But before we conduct our simple linear regression analysis, it is important to understand the data we are working with. So in this video, the data set we are using focuses on understanding the relationship between the price of cars and their age. So our dependent variable, the price of car here, is the outcome we want to predict or explain. This variable is continuous, meaning it can take on any value within a range. This is the outcome we are trying to predict, and it represents the market value of the car in Ringgit Malaysia. What about the independent variable? So here is our independent variable, the age of cars, the predictor that we believe influences the dependent variable. This variable is also continuous. It measures how many years old the car is. So the dataset contains 12 observations. Each observation represents the used car. So in this example, we aim to fit regression equation using SPSS. The next one is to construct the analysis of variance, ANOVA table using SPSS. And finally, we aim to produce the coefficient of determination, R square, and interpret its meaning in the context of this problem. Now that we have a good understanding of our data set, the next step is to analyze it using SPSS. Specifically, we will perform a simple linear regression analysis to quantify the relationship between the age of cars and their price. This will allow us to determine how much the price is expected to increase or decrease for each additional year of the car's age. So first, make sure that your dataset is loaded into SPSS, like the screenshot here. The variables should be clearly labeled. So in SPSS, you go to the top menu here and then click on Analyze. From the drop-down menu, select Regression and then you choose Linear. So you will have this linear regression dialog box, and then you move the price variable into the dependent field as it is the outcome we want to predict, and then you move the age variable into the independent field as it is the predictor. Once the variables are set, click on the Statistics button within this dialog box to open the options for additional statistics. So you will have the box here. Don't forget to tick the estimates, the confidence interval, and the model fit as well. And then you click Continue. Before running the analysis, you can also check the Plots option to create residual plots, which help us in diagnosing any potential issues with the regression model, such as nonlinearity or heteroscedasticity. In SPSS, you will come across two important terms, the standardized predicted and standardized residuals. These are standardized values that help us evaluate how well our regression model is performing. In practice, we often plot standardized residual against standardized predicted to visually check the assumptions of linear regression, such as linearity, homoscedasticity, the equal variance assumption, and the absence of outliers. If the plot shows a random scatter with no clear patterns, our model likely meets these assumptions. However, if we see a funnel shape, curve pattern, or large residuals, it might indicate issues like heterozygosity, nonlinearity, or the presence of outliers that we need to address. So for this purpose, you put the standardized predicted in this box and the standardized residual here, and then you can click continue. Finally, you can click OK. After running the regression analysis, SPSS provides several output tables. One of the most important tables is the coefficient table, as it contains the information needed to construct the regression equation. The table provides p-values for each coefficient under the significant column here. So this p-value help us determine whether the coefficients are statistically significant. If the p-value is less than 0.05, we can conclude that there is a statistically significant relationship between the variable. So in this case, we can see the p-value for the coefficient of the independent variable h of car is 0.001, which is less than significant level, 0.05. So we can see that there is a significant relationship between the h of cars and its price. Next, let's look at the column B here. So the first row of the B column provides the intercept, also called the constant. This is the predicted value of the dependent variable, in this case is price, when the independent variable h is 0. So let's look at the second row of the B column here. This value represents the amount by which the car's price is expected to decrease, because the minus here, for each additional year of each. So since the slope value is, again, the slope value is minus 1.438, it means that approximately for every year older the car gets, its price is expected to decrease by Ringgit Malaysia 1,400. So using the value from the coefficient table here, we can now write the regression equation in the form y hat, this is the constant value that you get here, 29, and minus, because the minus value here, 1.438 x representing our independent variable, the h of car. So this is the regression equation we obtained using the example of car's price and their age. So next, we have this analysis of variance or ANOVA table that helps us determine if our regression model is useful. Basically, it tells us whether our regression model is significant or not. So we have the F statistic here. It measures how well our model explains the variability in the dependent variable. So we obtain the F statistics here from the value of mean square, where this value can be obtained from the sum of squares here. So we have the p-value in the significant column here. It tells us if the F statistic is statistically significant. So if the p-value is less than 0.05, it means that our model is significant. So in this case, we can see here the p-value is 0.001, which is less than significance level, 0.05. Therefore, we can conclude that our regression model that measures the relationship between the car's price and also the age is significant. So next, by looking at the model summary output table here, we can have the value of coefficient of determination, or R square here. We can also have the value of adjusted R square. So the coefficient of determination, or R square, is another key value in regression analysis. It tells us how well our regression model explains the variability in the dependent variable. The R-square value can range from 0 to 1. It represents the proportion of the variance in the dependent variable. In our case, price, the car's price, that is predictable from the independent variable h. Let's look at the value here. we have 0.714, so it means that approximately 71.4% of total variation in the car's price is explained by the variation in age of car. So the remaining of the balance we have 28.6% can be explained by the other factors that are not included in the model. For example, it could be the car mileage. So again, the R-square of 0.714 suggests the model provides a strong explanation of the relationship between age and price, but there's still some variability in car prices that our model does not capture. In this chapter, we walked through a step-by-step SPSS analysis of simple linear regression, exploring the effect of car age on the car price. So with that, we have covered SPSS steps for simple linear regression analysis and also interpret the outputs, including the coefficients, evaluating model significance, and assessing model fit with the coefficient of determination or R-square. Thank you for watching. See you in the next chapter.